Okay, so first we're going to start with our rotation angles. And we know that we can rotate an angle around an axis. So let's talk about some of that key information that we have. So if I were to start at the origin, so I start my rotation of all of my angles at the origin. And if I write out that arm, this is my initial arm. So all of my angle rotations begin on my initial arm, which you'll notice is on the positive x-axis. If I were to rotate my angle, so a positive angle has me rotating through the first quadrant, which you'll recall we have quadrants 1, 2, 3, and 4. So if I were to rotate through that first quadrant, I'm going to create an angle that is formed between my initial arm and what I call this as my terminal arm. And I can label that as theta. That angle that is formed between my initial arm and my terminal arm is called my principal angle. I could have, however, continued from my initial arm. Let's say instead of stopping in quadrant 1, I had started at my initial arm where all of our angle rotations begin, and I continued to rotate up through the first quadrant, and let's say I rotated into the second quadrant and instead labeled that as angle theta. So my principal arm is formed between my initial arm and my terminal arm, and the angle that is created there is theta. So again, a positive angle rotates through that first quadrant. It can continue past the first quadrant, but our angle starts at our initial arm, and if I rotate up through that first quadrant, I know I am creating a positive angle. We also know that a principal angle can form a related acute angle, and that related acute angle is the angle that is created between the terminal arm and the x-axis. Often we represent that related acute angle with alpha. So I have my related acute angle, alpha. You will also sometimes see this as RAA. Key words here, acute, which means our related acute angle will always be less than 90 degrees. It's always positive, and it is the angle formed between the terminal arm and the x-axis. So we have our principal angle, and a principal angle can form a related acute angle. The last thing that we can talk about is we also have a negative angle. Our negative angle will always still start at our initial arm on that positive x-axis where all of our angle rotations begin. And instead of rising up through quadrant 1, a negative angle will drop through the fourth quadrant and rotate clockwise to create our negative angle. We can call that beta. And what we notice in this diagram is we can say that our principal angle, that's represented in green, and beta are coterminal angles, which means they have the same terminal arm. So the angle value that we see, we read one as positive and one as negative, but they are known as coterminal angles because they share the same terminal arm. So there's just some terminology from last year just to remind you of our rotation angles that I will be using throughout the course of this lesson and in our upcoming lessons. So the next portion of our lesson that we need to review are our special triangles, because we will be using these special triangles for the next week in the calculations that we do. So our special triangles allow us to give exact values for our ratios. And so very few times today will I put things into degrees to then turn them into radians, because I want us to start to shift our thinking into radians. But since we're drawing on our previous knowledge, what I want you to keep in mind is this pi by 4 triangle. Pi by 4, you'll recall from our previous lesson, is really our 45-degree angle. So that used to be a 45, 45, 90 degree triangle. Our pi by 6 would have been, if I'm thinking about pi and I'm dividing it into 6, so I'm dividing it by a large number, which means I'm going to have a small angle, which is our 30-degree angle. So when you're picturing those triangles, just so you can relate at the beginning of this, right, our pi by 4 is really our 45-degree triangle, and our pi by 6 is really our 30, 60, 90 triangle. So I'm going to get rid of those, but I just wanted to remind us of those. So let's again come up with these triangles. So if you think about it, this is our pi by 2 angle. If I cut pi by 2 in half, I get my pi by 4, which means this was originally a square. If I think about how I can create this triangle, so that means it was originally a square, which means these side lengths here have to be equal. So if I think about what those side lengths are, the easiest value to think about a length of those side lengths would be 1 and 1. If I use Pythagorean theorem, I find out that my hypotenuse is root 2. So there we have our pi by 4 triangle gives us side lengths of 1, 1, root 2. Our pi by 6 triangle, so we have a pi by 6, a pi by 3, and a pi by 2 triangle. If you were to type into your calculator, so if we were just to play around with our calculator for a minute, and if we were to type in sine of pi by 6, so again, our calculator would be in radians, I would get a ratio of 1 over 2, or you would get a value of 1/2. So let's use that value. Sine of pi by 6, we know sine is opposite over hypotenuse, so it's opposite over the hypotenuse. So if my opposite side is 1, my hypotenuse is 2. And if I use Pythagorean theorem, 2 squared minus 1 squared, so 4 minus 1 is 3. Take the square root of that. I get root 3 as my other side length. So for our pi by 6 triangle, I have side lengths 1, root 3, and 2. Now I'm hoping when we look at that triangle, we go, we don't say to ourselves, but there was 3. I'm pretty sure we learned 3 last year. I'm hoping we can recognize that this angle here would be our pi by 3. So it's just our perspective of which angle we are looking from. So our other triangle is our pi by 3 triangle, which we recognize that our pi by 3 triangle has the same side lengths of 1, root 3, and 2. And that really, our pi by 6, pi by 3, pi by 2 triangle is really the same triangle. It just is going to rotate based on which angle we are looking for. Couple of things that I want us to be mindful of. Across from our smallest angle, and again, I've taken pi and I've cut it into 6. So because I've divided by a larger number, the value that I get is actually smaller, right? If you're cutting a pie into 6 pieces versus 3 pieces, if you cut it into 6 pieces, everyone will have a smaller piece of pie. Across from my smallest angle is my smallest side length. We know our pi by 2 angle is going to be our largest angle, and across from it is our hypotenuse, which should be our longest side length. And then across from our middle angle is our middle side length, right? So when we're coming up with the orientation of this triangle, we can use our knowledge of triangles to help us with that. So across from my smallest triangle is my smallest side length. Across from my largest angle is my largest side length. So those two triangles are what we are going to be using for the rest of our lesson today. Okay, so now we're going to use our special triangles and our knowledge of rotation angles to help us solve these next questions. So it's asking us to find the exact value of each ratio. And our rotation angles can be useful here, as well as our knowledge of our triangles. So we are thinking about sine of pi by 3. So I'm going to use my rotation. I'm going to write my axes. And I'm taking pi, which I know is a half rotation, and I'm dividing it into thirds. So I'm going to have a large angle here. So this is my angle that is formed. So that angle there, I know is my angle pi by 3. I can then use my special triangle to help me come up with an exact value for that ratio. So I know if I'm dividing by the smaller value of pi by 3, I'm going to have my bigger angle. And across from that bigger angle is going to be my bigger side length, which was root 3. I know across from my square, it's going to be the hypotenuse, which is my largest side length, which will be a 2. And because that gives me my opposite over my hypotenuse, I don't have to go further in labeling my triangle, but maybe just to ensure, I write my adjacent side there, which is 1. So we find out that the value of sine pi by 3 is root 3 over 2. So that would be the exact value of sine pi by 3. So I've used my knowledge of the unit circle, I've used my knowledge of rotation angles, and I've used my knowledge of special triangles to help me come up with that. So continuing on, let's do one more together, and then I'm going to give you one to try on your own. Sine 4 pi by 3. So the nice part about using radians is if we look at this, we have 4 thirds. So I know 3/3 would have gotten me to this rotation here, which would have given me pi. But I am pi by 3. I'm 1/3 radians past that, which lets me rotate another 1/3. Let me just fix the size of that angle there. So I know I have rotated another pi by 3. Okay? So what's also nice about radians is it tells me right away what my related acute angle. I know I rotated another pi by 3 past pi, so my related acute angle is pi by 3. I can use my knowledge of special triangles to draw my triangle for me. I know across from my pi by 3 angle will be root 3. Across from my largest angle, which is pi by 2, will be my hypotenuse, which has a side length of 2. And again, since I'm being asked about sine, which is opposite over hypotenuse, I can stop my labeling there. However, I could put on my side length of 1. Now, the difference in this question that we need to be aware of is we have rotated into quadrant 3. You'll notice the vertical portion of my triangle is below the x-axis. So I'm going down. So it should be a negative root 3. And I'm going across the x-axis to the left of the origin. So that should be a negative 1. So the value of sine 4 pi by 3, we've rotated into the third quadrant because we've rotated pi by 3 past pi. And we've drawn our special triangle, and sine of 4 pi by 3 gives me opposite over hypotenuse, which gives me a negative root 3 over 2. So I want you to take a moment and to see if you can come up with your triangle and your axes. So draw your set of axes, rotate your terminal arm, reminding yourself that we always start at that initial arm, which is on our positive x-axis. Rotate your terminal arm, and in this case we have a positive 5 pi by 6 angle and a positive 3 pi by 4 angle. So let's start on that positive initial arm, and we're going to rotate up through the first quadrant. Draw your axes with your terminal arm, and then see if you can draw on your special triangle, and then calculate the ratio of that. So I'm going to give you a couple of minutes to try that. Okay, so let's see how we did for C. So I'm going to start by drawing on my axes. I have 5 pi by 6. So I have rotated, it's a positive angle, so I've started at my initial arm, I've rotated through quadrant 1. And I am pi by 6 shy of a half rotation there, right? Pi by 6 more would give me 6 pi by 6, which would give me pi. So this angle here is 5 pi by 6. We use our related acute angle. So again, the nice bit about radian measure is it's really easy to see what our related acute angle is, which would be pi by 6. I can draw my special triangle. I know if I'm taking pi and I'm dividing it by 6, I'm dividing it by the biggest number. So I will have my smallest angle. Across from my smallest angle is my smallest side length, which is 1. My hypotenuse is always 2 for this triangle, and the adjacent side then will be a negative root 3. Cos is adjacent over hypotenuse, so the answer to cos 5 pi by 6 gives me an exact ratio of root 3 over 2. So now when I look at D, I'm given tan 3 pi by 4, so I recognize I've been given my angle. I'm going to rotate, and I notice that I am at 3 pi by 4, which means I am pi by 4 shy of a half rotation. So this angle here is 3 pi by 4, which means I can use my related acute angle of pi by 4, create my triangle. Across from pi by 4 is 1, adjacent to pi by 4 is 1, and my hypotenuse for this triangle is root 2. since I am on the negative x-axis, this should be a value of -1 for my adjacent side. So tan of 3 pi by 4 should give me a value of -1. So our 3 pi by 4 allows us to rotate the angle of 3 pi by 4, and then we use our related acute angle to calculate the ratio that we are given. Okay, so we know that tan 3 pi by 4 should give us a value of -1. So its opposite, the relationship of its opposite side to its adjacent side is -1. So I'm going to give you a minute to try this one as well. So you'll notice we have cos of -5 pi by 3. So that negative tells us we have a negative angle, which means I still start at my initial arm, but I should be dropping through the fourth quadrant and rotating clockwise. So take a moment to draw the location of -5 pi by 3 and draw on your triangle to see if you can find the ratio of this angle. Okay, so let's see how we did. So, like I mentioned, we are starting at our initial x-axis. We are dropping our initial arm through the fourth quadrant to rotate. So our terminal arm is rotating around through that fourth quadrant, and we're at 5 pi by 3, a -5 pi by 3, which means I have rotated and I am pi by 3 shy of a full rotation. Okay, so I'm 1/3 short of the x-axis. We could double check that. We had 2 pi minus pi by 3. If I got a common denominator, it would give me 6 pi by 3 minus pi by 3, which gives me 5 pi by 3, right? So I'm 5 pi by 3 is pi by 3 shy of a full rotation, and in this case, instead of rotating through the first quadrant, I drop that terminal arm through the fourth quadrant and rotate clockwise. So this angle here is my -5 pi by 3. However, I'm going to use my related acute angle to help me. So again, pi by 3 across from pi by 3 will give me my √3. My hypotenuse is going to be 2, and then my adjacent side will be 1. I've moved to the right of my x-axis, so my adjacent side is positive. The vertical portion of my triangle is above the x-axis, so it is positive. So cos is adjacent over hypotenuse. So cos of -5 pi by 3 gives me a ratio of 1/2. So in our last question, you knew the angle, right? We said sine 3 pi by 4, and I asked you for what the ratio was. So what was the value at sine of 3 pi by 4, right? In this case, you'll notice that we have the ratio, and now I'm asking you to find me the angles that this is true. And you'll also notice I have the notation if theta is between 0 and 2 pi, find the measures of theta if. So I want you to think about that notation. What that's really saying is if we think about 0 to 2 pi, that's talking about in the first positive rotation. So in our first positive rotation, because we're rotating from 0 to 2 pi, so in our first rotation, in our positive rotation, what are the values of theta given the specific ratio? Okay, so that's what we're thinking about here. So if I have one positive rotation, what are the angles that when I take sine of those angles, I get a ratio of 1/2? So that's what we're looking at here. Before we get into actually calculating those values, I want to talk to you for a moment. Last year, this would have been for some of you where you may have learned the CAST rule, okay? So you learned the CAST rule to try to help you remember for which quadrants were different ratios positive. I'm going to encourage us to move away from the CAST rule because I think it has some limitations to it. And instead, I'm going to have us rely on our grade 10 knowledge of SOHCAHTOA and our grade 9 knowledge of integers and plotting points to help us with this instead. Because I do think that our CAST rule is a set of rules that has some limitations to it, okay? So I'm going to, if you're familiar with that, I'm going to encourage you to move away from it. Okay. So what is this question asking me? This question is saying, we're being asked about our sign ratio, and we notice that our sign ratio is positive. I have a positive 1/2. We know that sine is opposite over hypotenuse. So we have our opposite side, our hypotenuse. We've already talked about our hypotenuse is always positive because our diagonals don't have direction symbols. Our opposite side is vertical. So when we think about that, our opposite side is vertical. So what this is saying is, where is our vertical side positive? Well, when we think about when is our vertical side positive, that should be when it's up, right? So our vertical side is positive when we have positive y values. Okay, so our vertical side is positive when it's up. So these are our possible locations of where sine could have a positive ratio. So our first, we know sine is opposite over hypotenuse. So if this is my first value of theta, opposite over hypotenuse, this is the angle that is created. Or the second angle that might be created, we use our related acute angle, opposite over hypotenuse. And then from there, we can recognize, well, if I have my opposite side is 1, that is my smallest side length. The angle that corresponds to my smallest side length is my smallest angle. So I know that theta could equal pi by 6 because pi by 6 is the smallest angle and it's across from my smallest side length. So if that's pi by 6, I know my related acute angle is pi by 6, which means I am pi by 6 shy of a pi rotation. So that means my other angle is going to be pi by 6 less than pi, which is 5 pi by 6. So there are two possible angles that when I take sine of those angles, I get a ratio of 1/2. So you could type sine of pi by 6 into your calculator and you would get a ratio of 1/2. You could type sine 5 pi by 6 into your calculator and you would get a ratio of 1/2. So this is where we're going to move to with our next type of questions. Obviously, we're going to continue when we're given our special triangles to give exact values. So the expectation is that we are using our special triangles to give exact values when a special triangle can be used. The other piece I just want to talk about in terms of how do we recognize where those terminal arms are located. So for sine, we know sine is opposite over hypotenuse. And if our hypotenuse is always positive, then we can just think about for sine, what is happening with the opposite side? So when I think about where are those terminal arms being located, what's happening with the opposite side? For cos is adjacent over hypotenuse, and if the hypotenuse is always positive, then I'm thinking about what is happening with the adjacent side. And adjacent meaning horizontal, right? So what is happening to the horizontal side? So when you think about an angle that's adjacent, it's beside, okay? The only one, though, that we have to really think about in terms of taking into account two sides is tan, because tan is opposite over adjacent. So both of our signs in tan can change. So when I have a ratio that's based on tan, I want to think about if tan of theta, if that ratio that I'm given is positive, then the top and bottom have to have the same signs. So I'm either moving to the right and up, which would give me two positives, or to the left and down, which would give me two negatives, which we know makes a positive. Or if tan of theta equals a negative, then we know that the top and bottom signs are different. So we will continue to use that theory to help us with our next couple of questions. So let's do that. So let's look at B together. So I've been told that cos, so I'm working with my ratio of cos, and cos is negative. When I think about cos deals with my adjacent sides. So where is my adjacent side negative? My adjacent side is negative on the x-axis. So possible locations of my terminal arm have to be when my adjacent side is negative. So I rotate. There's theta. So that would be my first rotation. My second rotation. So those would be our two locations of our terminal arms. I've been given information about what my ratio is. So I'm going to use my related acute angle. I know my adjacent side is negative, which is why we have our terminal arms located where we do. Our adjacent side is a negative, and our hypotenuse is a root 2. I can label the rest of that triangle, but I don't have to. So if I wanted to label the rest of that triangle, I could, but again, I don't have to. And now I'm going to use my knowledge of special triangles, and I know my special triangle where I have an adjacent side of a negative 1 over my hypotenuse, which is root 2, is going to be my pi by 4 triangle. So my related acute angle is pi by 4. So for that first rotation, I notice I am pi by 4 shy of a pi rotation. So I am a quarter less. So I will have 3 pi by 4. Or for my other rotation for theta, I know I am pi by 4 more than a pi rotation. So I have pi plus a pi by 4, which means I have 5 pi by 4s. Again, keeping in mind our pi rotation. If I were to write that with a common denominator, since this is pi by 4, that would be 4 pi by 4. So 4 pi by 4 minus pi by 4 gives me that first angle. 4 pi by 4 plus pi by 4 gives me that next angle. So let's do this one. So sine of theta is equal to root 3 over 2. So I notice that sine is positive because there's a positive out in front of my ratio. We just don't write it. So sine deals with opposite over hypotenuse. So the opposite side is positive, which means my vertical is positive. I can label from those angles. I know opposite is root 3 over 2. Root 3 over 2. Looking at my special triangles, thinking about them, I know across from root 3 is my middle size side length, which means it will be across from my middle angle, which gives us our pi by 3. So in this case, when I go to rotate to my first terminal arm, it's pretty easy to see. It's just a pi by 3 rotation. To rotate to my next terminal arm, I recognize that I am pi by 3 shy of a pi rotation. So pi minus pi by 3 will give me 2 pi by 3. So take a moment and try to work on tan theta equals negative 1 over root 3. So take a moment, identify which quadrants you would have your terminal arms, and then write on your special triangles. Okay, so let's see how we did with finding our location. So I'll draw my axes. I know that tan is negative, so that means I have to have opposite of signs for my top and bottom. So if I move to the right, that's going to be positive, so I would have to move to the right and down, or to the left and up. So again, our rotation, so this would be our first angle. We've rotated. I can use my related acute angle to help me. So from this angle here, I'm going to use my related acute angle, and I know that I have opposite over adjacent. My rotation for my second angle, I'm going to use my related acute angle, and again, I have opposite over adjacent. I can draw on the rest of my special triangle if that's helpful to me. And I know that this is a pi by 3, pi by 6, pi by 2 triangle. And so across from my smallest side length is my smallest angle. Oops, pi by 6. So now when I go to give the value of theta, I know for my first rotation, I am pi by 6 shy of a pi rotation. So again, my 6 pi by 6 minus pi by 6. So I'm 1 pi by 6 shy, which will give me my 5 pi by 6. Or we notice as I rotate, I am pi by 6 shy of a full rotation, which would give me 11 pi by 6. And again, just a reminder there, we know a full rotation is 2 pi. So 2 pi minus pi by 6. If I get my common denominator, gives me that 11 pi by 6. Again, I do not need to see that calculation there. So now if we take a look at E, we'll notice a few things. We notice that sine, my ratio for sine is negative, which when we're thinking about sine is opposite. Opposite means vertical. So where are our opposite sides? Our vertical sides negative. So my vertical side is negative in quadrants 3 and quadrants 4. I can fill in those values, opposite over hypotenuse. So negative 5 over 13, negative 5 over 13. So again, we're going to use our related acute angle. to help us in this case, except what you're going to notice is that we do not have a special triangle for this. So the negative that we used here told us the quadrant location of our sine. So the ratio for sine was a negative 5/13. And we know that the ratio for sine is negative when our opposite side is negative, which led me to draw my terminal arms in quadrants 3 and quadrants 4. So we've used the sine to tell us the location of our quadrant. I then am going to use my knowledge of our related acute angle to help me find out what the value of our related acute angle is. So to do that, I am going to calculate my related acute angle, and what you'll notice is I am using the positive ratio. So we've used up our negative here. We've used that up to tell us which quadrants we're located in. And now we're actually going to just use the value to help us find our angle. Okay, so now we're going to use the number portion for our size. We used our negative to tell us quadrant location. Now we're going to use the number portion for our size. So you will need to make sure that your calculator is in radians. Again, I don't need to see this step, but this is what we're typing in. And we will get our related acute angle is approximately 0.39. Now the key here is to remember that what you just calculated was our related acute angle. That is the angle that is formed between our terminal arm and the x-axis. That is not our final answer. In order to calculate the value of theta, I start at my initial arm, I rotate. So for my first value of theta, I've rotated pi units plus 0.39. So I get an angle of approximately 3.53 radians. For my other angle, again, I start at my initial arm and I rotate, and we notice that I am 0.39 radians shy of a full rotation. So I'm going to say 2 pi minus 0.39, which will give me an angle of approximately 5.89 radians. And again, the original question asked us to find the values of theta between 0 and 2 pi, which we described in words as find your values of theta that belong in your first positive rotation. So again, to satisfy the original statement, we are being asked to find between 0 and 2 pi, which means we're being asked to find our angles within our first positive rotation. So you'll notice in example E, we do not have a special triangle, so at this point we would have to use our calculator, and we would need to ensure that our calculator is in radians. So when we look at example F, we should be noticing a few things. We know that cos, we're dealing with our ratio of cos. It's when cos is negative. Cos is dealing with adjacent. So when our adjacent side is negative, which means we need to have a negative x value, which means cos will be a negative cos has terminal arms in quadrants 2 and quadrants 3. We can draw our triangles. We notice that we have -7 adjacent over our hypotenuse. And then I recognize that I do not have a special triangle. So I have used the negative to tell me which quadrant my terminal arms located in for cos. and then I'm going to use my related acute angle with the positive ratio. So I'm going to use just the numbers to give me my related acute angle. Okay, so now this is going to help me find the size of the angle. So again, the negative told me which quadrants, the actual just numbers without a negative sign using positive ratio will tell me the size of my related acute angle. So at this point, I'm going to type that into my calculator. So second cos, 7 divided by 11, and I'm going to get a related acute angle of approximately 0.88 radians. So again, please keep in mind what you just calculated was your related acute angle. To calculate our values for theta, if I start at my initial arm and I rotate to my first terminal arm, I am 0.88 shy of a pi rotation. So I'm going to take pi minus 0.88, which will give me approximately 2.26 radians. So my first angle is approximately 2.26 radians. If I start at my initial arm and I rotate to my terminal arm, I notice I rotate pi units plus 0.88. So I'm rotating pi plus 0.88, which will take me to my next terminal arm, which is approximately 4.02 radians. So the last piece that we need to review is what if the angle lies on the axes, right? So if I rotated 0 or 2 pi and my terminal arm is lying on that axis. So if I've rotated and it actually lands on an axis, how can I calculate that ratio? So for example, if I'm asked for sine of 0, so again, now I've given you the angle, you need to calculate that ratio. Okay, so what if cos is 0 or sine is 2 pi? So, and the terminal is lying back on that initial arm. I need to think about how can I calculate this? So I'm going to draw what I call an imaginary triangle. The reason being is I want you to think about here, what side does not exist, right? So right now, if it's lying on our terminal arm, I'm hoping that we notice that really there's no vertical side here. This side does not exist, right? It's lying on top of itself, so it does not exist. So our adjacent side would be 1, and our hypotenuse would be 1, right? If you think about even just using your Pythagorean theorem there. So what I want to think about here is our opposite side. Opposite side is equaling 0 because it does not exist here, okay? So for sine of 0, we would have our opposite side over our hypotenuse, which would be 0. For cos of 0, we would have our adjacent side over our hypotenuse, which would be 1. And tan of 0 would be our opposite over adjacent, which would give us a value of 0. So we can continue on and we can move. And what if instead our initial arm rotated and our terminal arm landed on our y-axis here? So now what if I asked you for the value of sine pi by 2? Or what if I asked you for the value of cos pi by 2? Or tan of pi by 2? So our terminal arm is on the y-axis. So really, it's vertical. So I'm hoping we can see if it's vertical, then really the side that does not exist is anything that is adjacent. Okay? There is no adjacent side. So again, this is an imaginary triangle. There's no adjacent side. We still have our vertical, which would be 1, and we would still have our hypotenuse, which would be 1. So if our adjacent side does not exist, we can think our adjacent side is equal to 0. The length of it would be 0. So sine is opposite over hypotenuse, so sine would have a value of 1. Cos deals with our cos of pi by 2 is adjacent over hypotenuse, and at this location, at pi by 2, our adjacent side does not exist, so that would be 0 over 1. Tan is opposite over adjacent, so tan would be 1 over 0, which we would really write as undefined. So as we become more familiar with this understanding of which side does not exist, I'm going to encourage us to move away from drawing these imaginary triangles. And so let's move on. And what if I asked you about pi? So if I asked you, what is sine of pi? Well, if I think of where pi is located, it means I have an adjacent side here, but I have no y value. It has not moved off of that axis. So my opposite side, I have no opposite side. So I can think the opposite side has a length of 0. So at sine of pi, my opposite side is 0. Cos, my opposite side would have a length of 1, except since we're on the negative x-axis, it would be a negative 1. And tan, since tan is opposite over adjacent, and our opposite side here, our y value is 0, tan of pi would be 0. So let's continue on. If I were to continue on, and now if I were to ask you, well, what about sine of 3 pi by 2? I can locate where sine is. It's on my negative y-axis. So I have a vertical distance, but I have no adjacent side. So I have no adjacent side. It does not exist, so I know my adjacent side is equal to 0. So if sine is opposite over hypotenuse, I know opposite side exists here. It would give me a negative 1. Cos is adjacent. Well, we know our adjacent side does not exist here at 0, so cos is going to be 0. And tan is the one we just have to compare the two together. Tan is opposite over adjacent, which means it would be undefined. So if we think about which side does not exist, then that can help us when determining the ratios for angles on our axes. So now we've talked about being able to state the ratio when we are given an angle, but we also need to be able to work backwards from like the questions that we were just doing before. So you'll notice I've now given you sine. So for what angles of theta does sine have a ratio of 0? So we know that sine is opposite over hypotenuse. So our opposite side is 0. So if our opposite side is 0, that means it does not go up or down. So when is it? My opposite sides are 0, are going to be on the positive and the negative x-axis because I have not moved up or down. So for what values of theta can sine equal 0? Well, it's going to equal 0 at 0, pi, and I could rotate all the way around, or 2 pi. So in our next example, when is cos theta, when does cos equal 0? Well, we know that this would mean where our adjacent side is equal to 0. And if our adjacent side is equal to 0, that means we have not moved left or right. So if I have not moved left or right, that means I've only moved up or down. So what values of theta make cos equal to 0? Well, if I look at those locations on my axes, I know that theta could be pi by 2 or 3 pi by 2. If here cos of theta equals 0 means the adjacent side is 0, it does not have a value, it does not exist. So we only moved up and down for our vertical. If we look at example I, we have cos of theta equals 1. So now we could think about it that this means our adjacent side, if cos is adjacent and our adjacent side equals 1, that means that our adjacent side equals everything, or cos equals everything. So where is cos is adjacent? Where can it equal 1? So now where do we have adjacent values? So we have adjacent values because it equals to 1 along our x-axis. But I'm hoping we recognized that to the left of our origin is negative values. And if cos is equaling 1, then we know our values of theta could be 0 or 2 pi, right? So they're on our initial arm, and our terminal arm falls on that positive x-axis, which would give us 0 or 2 pi. Okay, so this would mean our adjacent side is everything, and our vertical is nothing. It is 0. So lastly, let's look at when tan of theta is equal to 0. So tan of theta, our opposite side is 0. So our opposite side we think of is vertical. So our opposite side is 0, so our vertical is 0. So this means we have not moved up or down. But then our adjacent can be everything. And in this case, so our adjacent, 0 over 1, 0 over negative 1 is still 0. So since our opposite is 0, our vertical is 0, we have not moved up or down, but rather we have moved left and right. If we think about where does that triangle exist. So we could say therefore theta can be 0. So this would give us 0. This would give us pi, or this would give us 2 pi. So those would all be possible values of theta. So if I took tan of 0, it would equal 0. If I took tan of pi, I would get a ratio of 0. If I took tan of 2 pi, I would get a ratio of 0. So those are the different types of questions that we were working with today. So we reviewed our terminology for rotation angles. We also reviewed our special triangles in radians. And then we looked at if I gave you sine of pi by 3, what would be the value of that ratio? And then in question 2, we moved on if I gave you sine of theta equals 1/2, what are possible values of theta in our first rotation between 0 and 2 pi? And then we extended that to, well, what happens with our angles that are located on the axes? So those are the different types of questions that we've looked at today. We will continue to build on those tomorrow. So you'll want to take some time to complete the practice work and let me know if you have any questions.